Hello, everybody. It's 10 sharp. We are waiting a little bit longer so that everybody can join us and can hear us from the very beginning. My name is Hildegard Meyer. I'm working at WWF Central and Eastern Europe based in Vienna. I am part of the NaturaConnect project, and I will be leading you through this excellent and very interesting webinar today dealing with navigating climate change. We will present methodologies and applications for conservation. Thank you for joining us and for your interest in this topic that certainly affects all of us in one way or the other. Temperatures are rising. This is what we can feel, and the number of disturbances is increasing, be they floods, fires, or droughts, and entire ecosystems are shifting in terms of both altitude and latitude. And as conservationists, we are naturally concerned about the well-being of the ecosystems on which we all depend. Many scientists and practitioners work on the assessment of ecosystem vulnerability as a basis for developing measures to mitigate or adapt to this transition, as our biodiversity is, as you all know, at risk. I would like to share with you some basic webinar guidance. So as you might have already recognized, the webinar is being recorded. If you have any questions or comments related to what is presented during this webinar, please put it to the chat, and also please indicate the speaker you would like to address with this question or comment. All presentations, the recording and the short report will be available after the meeting and will be shared with the registered participants. And also let us know who you are. So feel free to rename and state your organization by clicking on the three dots next to your name. I hope you can handle this. We would be happy to see that. And please start or stop your camera at your convenience. What can you expect for today? So I'm running through a little bit the agenda for today. First, I will briefly introduce you to the NaturaConnect project, to all of those who haven't heard about yet. Then we will turn our heads to the introduction to climate resilient planning and methodology presented by Moreno Di Marco from the Sapienza University of Rome, followed by the NaturaConnect methodology and applications for protected areas by Marta Cimatti, also from Sapienza University of Rome, followed by the NaturaConnect learning platform tutorial and practical application of this methodology presented by Valerio Mezzanotte from Sapienza University of Rome. And then in a second part, we will turn our heads to practical implications of climate change measures. And you will hear about assessing forest vulnerability to droughts and supporting adaptation strategy from José Atauri from Europac Spain, followed by by presenting the Forest Connect project, talking about pilot actions to adapt to climate-driven food scarcity for large carnivores by my colleague Maria Kachamova from WWF Bulgaria. And then, of course, we will have an open discussion. I'm very looking forward to this, and we will close the webinar at 11:30 sharp, I hope. So I would like to start for those who haven't heard about NaturaConnect yet. So I will present it to you in a nutshell. The project deals with designing a resilient and coherent trans-European network for nature and people, as stated in the Biodiversity Strategy 2030 from the European Union. The project started already in July 2022, and it will last only until September this year. So we are towards the end. We can present already some results, and one of these is we will present today. The NaturaConnect co-developed knowledge, tools, and capacity to support the countries realizing the European biodiversity strategy and its objectives, namely the 30% of land and sea should be protected by 2030, whereas 10% of these should be strictly protected, and Europe should establish the Trans-European Nature Network that connects protected areas on land and sea. Who who are working on this project. So the project consortium consists of 17 research institutions, 5 policy and practitioners, organizations spread across 12 countries across Europe. And the project lead is the International Institute for Applied System Analysis based in Austria, supported by the Martin Luther University, the Research Center for Biodiversity based in Leipzig in Germany. So I hope this is really in a nutshell, it's a very complex and very huge project, but this is the common ground in this project. So now, because we are quite anonymous here in this webinar, as always, we would like to know a little bit more from you. So please type in your browser menti.com and type the code that is given here, or use the QR code for entering the Mentimeter. I will stop sharing here because my colleague Marit Schnepf will share the Mentimeter questions. Good. Here again, you see the QR code and the menti.com, and I hope you can easily join it. I think if you have already participated in some of our webinars, you should be a champion on this already. So I see 4 people, 6 people joined, 23 joined. So let's wait a little bit longer before we go to the first question. Okay, 24. Maybe let's wait until we are 30, so that we have a good representative around. Okay, we have 30 joined. So the first question is very easy. Where are you joining us from today? We would like to see where are you based, to get a little bit of a glimpse. Oh, that's perfect. We have participants from the very south of Europe to the very north of Europe. I can see. That's great to see. Very good spread across Europe, and it's actually also we are working in NaturaConnect also across Europe. So good to see. Thanks for joining from so many different locations in Europe. Perhaps let's go to the next question. We would like to know a little bit what your primary expertise is or your background is, to see from which field of expertise you are and are interested in climate change measures. So there are a lot given here. So be it agriculture, forestry, fisheries, conservation policy, biodiversity, finance or impact investments, tourism, climate policy and nature-based solutions, use of civil society and academy, landscape or regional planning or other. Okay, I see most of you are working in biodiversity. This is what we expected, but we also would like to address, of course, all the other sectors, because we cannot, as conservationists, do everything on our own. We need to work all together on this. So it looks like, yeah, it looks like we are ready. So the next question would be related to what you see in your area as most prominent threat related to climate change. This is an open question. You just type a few word or half a sentence or whatever, what you see as the most important threat related to climate change in your region. I think when we look at last year, we had a lot of floods and weather disturbances in Spain, for example. Also, the Alps encountered disturbances, floods, and bad weather conditions. So I think we all are somehow aware of. So it's mainly drought. I see drought, heat waves, and consequent bushfires. I think this might come from the Mediterranean area. Yeah, and also along the Danube, sometimes we have drought seasons, extreme heat. Okay. Agricultural and land abandonment, diebacks, invasive species distribution also, and flooding and heavy rainfalls. True. hmm Okay. Um, I think we know now a little bit about your backgrounds and about your perception of climate change. And now I would like to thank you very much for your answers. And now I would like to introduce you to Moreno Di Marco. Please, if you want to share your presentation. Um, Moreno is a conservation biologist and associate professor of the Sapienza University of Rome. He leads the Biodiversity Change Lab, which is a research group at the Department of Biology and Biotechnologies. So two of his colleagues also joined this webinar and will present. Within NaturaConnect, he and his team developed a climate change assessment tool that is a practical tool for conservation planners who would like to integrate climate change into their management plans. He will present the approaches for climate resilient protected area planning and what kind of methods we use and why. So Moreno, the floor is yours.
Thank you very much. Can you just confirm you can see my screen?
Yes, all perfect.
Well, thanks very much, first of all, for the organization. It's really nice to see all these people connected and with a different background and from different parts of the world. I am Professor Moreno Di Marco from Sapienza University, and yes, indeed, my lab, the Biodiversity and Global Change Lab, deals with several matters which concerns the way in which biodiversity responds to global change drivers, land use change, climate change, and also what that means for the contribution that this biodiversity provides to us. And in particular, today, we will be discussing about one of the contributions we deliver to the NaturaConnect project, which is trying to inform climate proofing and resilient climate planning of protected areas at the European scale. And so you will hear from myself and two of my colleagues later on. So why climate resilient planning? Why is it important to discuss protected area planning in the face of climate change? And when I say protected area planning, I'm referring both to the management of existing protected areas and the designation of new protected areas under the 30 by 30 strategy. Well, I think if you are connected here, you are all familiar with the issue of climate change. The average climate velocity in European protected area is between 1 and 3 kilometers per year, which is faster than a lot of species which are supposed to thrive in those protected areas. You will hear all the details about this from Marta and Valeria in a minute. And the average climate magnitude is also high. It's 4 to 6 times higher than the standard deviation, meaning that the predicted effect of climate change in the future is going to be much higher than the variability of climate change in the recent past. And so our species is going to be able to adapt to those changing climatic conditions. Our habitat's going to be able to adapt. And we see that in front of our eyes every year. You see a picture on the right-hand side of the slide. That's from Doñana National Park. This is a particularly dry year, which is happening more and more frequently, unfortunately. That was 2022. And due to dry condition and the increased frequency in extreme aridity, a large part of that area is becoming arid. Essentially, entire lagoons are disappearing. And that is reshaping completely the landscape of that protected area and generating dramatic consequences, both for the biodiversity and the human activities that live in that area. In response to this crisis, the European Union has, of course, decided to climate-proof every environmental action which is being proposed. Of course, this is guided by the European Climate Law, where the European Union is committed to achieve a reduction in climate-altering emission of 20% by 2020, and we actually cut even more than that, and then increase that commitment to 55% by 2030 and get to an actual net zero by 2050. Now, climate change is connected as a double edge to every major environmental policy, be it the European Green Deal or the Common Agricultural Policy or the Nature Restoration Law. it's important to understand that each of these policies are actually committed to contributing to the reduction of climate change, which is a mitigation target, but they also face the consequences of not achieving those climate reduction. The way in which you conserve biodiversity, the way in which you define areas for restoration, the way in which you define an agricultural strategy for sustainable cropland production, they all must respond to a climate-proofing planning. And so what are the approaches for climate-proofing planning? This is the question we asked ourselves before embarking in this journey for NaturaConnect. So there is a recent literature on the topic which came out last year, which essentially points towards four main approaches that conservation planners around the world have adopted to deal with the effect of climate change. At its simplest, you can deal with the effects of climate change by identifying so-called refugia. So focusing your conservation and protection measures in areas which are supposed to not change their climate, or at least not change it by too much. So if you identify the areas which have a relatively stable climatic condition now, and they are predicted to maintain those conditions in the future, then those areas will be climatic refugia, meaning that if you protect those areas, the biodiversity included in the areas will likely face limited impact from climate change. So they will thrive and stay in the same climatic condition. And those are relatively safe bets. Another approach stems from the fact that the climate is going to change in most part of the world and by quite a lot, meaning that there is not going to be a lot of options for climatic refugia. Yes, there will be some area with slower changes, but for the most part, we need to be able to learn how to cope with the consequences of climate change to some extent, meaning that a protected area established today will likely experience a change in climatic condition in the future, meaning that the species living in that area will likely face a change in the climatic condition they're adapted to. And in that case, identify where suitable climatic condition might move into the future and whether there can be any connectivity between current climatic condition and similar condition in the future is actually a good strategy. If you can generate a system of protected areas that allows species to move, to maintain certain desired climatic conditions, then of course you are future-proofing your protected area system, meaning that the same species which today lives in an area might be able to move into an area which is also suitable in the future. So in other words, if you cannot find a refuge, try to deal with climatic connectivity, improve the connectivity of your protected area system. And then lastly, climate resilience planning must account for the fact that species can adapt to some extent to changing climatic conditions. And so in protecting your species, you can, for example, try to understand whether different populations of the same species, different individuals, carry with them genetic variability, which might allow adaptation potential. So the ability of a certain species to adapt to changing climatic conditions. Without assuming that species cannot survive climate change, we can instead assume that we can maximize the ability of species to cope with climate change. So these are the four main theoretical approaches that conservation planners around the world have been using to try and maximize the future-proofing and the resilience of their conservation action, specifically protected areas, to climate change. Now, as part of the NaturaConnect project, we embarked in a journey which actually encompassed each and every of those four main approaches. NaturaConnect is committed not only to identify the best option for a trans-European nature network, but also to identify the best option to climate-proof that network, to make that network as resilient as possible to future changing climatic conditions. And we have done all of the strategies mentioned before. We identified the current suitable condition for the species and how that condition might move into the future. We have identified potential connectivity corridors that can connect the currently suitable condition for a species with the potentially future condition that the species might experience when climate is going to change under different scenarios. We identified areas that might have a more stable climatic condition compared to other. And we haven't done it in a simple binary way. You will hear in a minute that we have done it in a very complex and continuous way. So instead of focusing on climatic refugia, we actually identified the full spectrum of climatic exposure, leaving it to protected area manager to decide which level of exposure their particular habitat of interest can tolerate. And then, of course, we even accounted for the adaptive potential of species. So accounting for the fact that a lot of European species live in different climatic conditions, depending on whether they are, for example, in the Mediterranean or temperate or alpine region, meaning that if you come up with a system of protected area that protects every population, then you're maximizing the adaptation potential. Now, the focus of today's presentation, we're not going to have time to discuss all of those things. The focus of today's presentation is about climate change exposure. The reason why we're focusing on climate change exposure is that this is a big problem in Europe, and this is not a problem of the future, this is a problem of today. Europe is warming faster than most other regions of the world. The global average, the average of global warming in Europe is 2.4 degrees, which is almost twice as fast as the average global warming of the world. That means that understanding where this climate change, this climatic exposure is going to be higher is definitely the first and most important step to then allocate and guide conservation intervention for adaptation. And of course, if you understand where climate exposure is going to happen, what type of climate exposure is going to happen, and what level of climate exposure is going to happen, you can then define climate change adaptation action. So the focus of the next presentation is entirely on how we measure a climatic exposure and where are the highest level of exposure in Europe and what you can do about it. And with that, I'm going to stop my presentation and I am ready to take a quick question if there is one.
Yeah, if you have any questions, I saw there was one question, but it's not relevant. We are also working in Natura 2000 sites. They are taken into account here, as you could see. Anybody? I see a lot of applause, which is nice to see. So it's nice that you react on what we present to you. Okay, if there is no any questions, I would like to introduce you to Marta Cimati. She is a postdoc at the Biodiversity Change Lab, working with Moreno Di Marco, and among many others, she published an article about accelerating exposures of protected areas to climate change. Marta will tell us about the climate change assessment methodology, which was developed by the team. We are curious to see how the assessment tool can be applied in protected areas or other lands. So, Marta, the floor is yours.
Yeah, so good morning, everyone. And now we'll give you some more detail about how you can measure climate exposure. So, climate change has been measured mainly focusing on increase of mean value or the frequency of extreme events, but that doesn't give us a way to understand how the species could counteract climate change. So now there's been developed different variables like landscape metrics or climate metrics, then are complementary to each other and give us different information on the climate exposure. First, we have local climate velocity that give us information about the speed and direction of change. And then the analog climate velocity that give us information about the distance of analog climate in the future. And then climate magnitude that give us information about the intensity of change in the future compared to present condition. So to climate-proof protected areas, we need to consider all these three metrics at the same time. First is local climate velocity that basically describe how isoplate of the climate or same condition move across the landscape. And it's defined considering the temporal change of a variable divided by its spatial gradient. So if a useful analogy to understand how it works, we can take the example of the treadmill, like how fast a species need to move to chase its present climate condition. And if the climate moves faster, then the species will not be able to keep the same condition. So in this case, one key factor to consider is the topography. And climate velocity usually is slower in mountainous areas compared to flat areas, because let's say in a vertical space, moving very little distance, we can have a high change of, for example, temperature. Then we have climate magnitude, which basically tell us how much a variable change compare to present condition. And it's a difference between future and the present condition divided by its variability in the present. So this is a dimensional variable, and basically it tells us how much it changed. So if it's a magnitude of 1, we are still in a safe climate, let's say, that didn't change much compared to the present period. But then a value of 2 or 3 tell us that the climate will have a variability that is twice or thrice higher than the present condition, and probably the species will not have the capacity to adapt to this new novel climate. So we apply climate exposure to two different bioclimatic variables, the temperature and the precipitation at 1 kilometer resolution. We also produce another variables which analog climate. And then to consider uncertainty, we take into account 3 different socioeconomic development scenarios, which are linked to the gas emission and different increase of temperature in the future, and also consider different Earth system models. So then we produce the ensemble model for the historical period and future, and then we compare the climate exposure values inside and outside protected areas using also propensity score matching, which enable us to have a unbiased comparison between protected areas and the surrounding landscape. So here you can see the results of local climate velocity under the scenarios SSP 3.7. And so under these scenarios, we have a median value across Europe that is 2.2 kilometers per year. And you can see that in the red colors, we have higher values of local velocity, which are found mainly in flat areas, and then lower values in yellow in flat areas. So then if we look at the spatial heterogeneity of the local climate velocity, we can see that the Pannonian region, where actually the Danube-Carpathian region is located, is one of the most exposed. And we can see that local velocity increase under different socioeconomic development scenarios. And this box plot also tells us that protected areas, which are the box plot in the lighter color, have higher values of local velocity compared to the control site, meaning that protected areas are more exposed to climate change compared to control sites. So similarly, here we have the results for the magnitude, and which are mostly complementary to local velocity, meaning that we have higher values of magnitude in mountainous areas compared to flat areas. And most exposed biome here in this case are the alpine and Arctic biome. But here the values of the magnitude are more heterogenic, so we cannot really say that protected areas are more or less exposed compared to their control sites. But as in the case of local velocity, we have increased magnitude value going to more extreme socio-economic development scenarios. Then here you can see a bivariate map of the two metrics that can help us to identify hotspots of climate exposure, like meaning areas that go to fast changes, but also very intense. And you can see these areas depicted in dark green, and they are mostly in the northeast of Europe, but also flat areas of Italy and somewhere in Spain. At the same time, if we can also see what are the cold spots. So areas where we have very low local velocity and magnitude, which are more or less scattered across Central Europe and Portugal. So to summarize our results, we can say that we have an increasing risk to different socioeconomic scenarios, and that protected areas have higher or similar exposure to control sites. But one very important thing is that protected areas, like more than half of the protected areas that we have in Europe, are somewhat exposed and overlap with hotspots, while only the 2% of protected areas can be found in cold spots. So even if we have almost reached the 30 by 30 objective, as we have 26% of protected areas in Europe, half of it is exposed to climate change. So what we can say is that considering climate exposure within conservation planning, it's of the utmost importance. And if we do not consider this in the future planning, then we risk that protected areas will lose their effectiveness. So the first thing that we need to do is to highlight what are the most exposed areas and species to try to understand what could be the best adaptation action. One example could be to protect climate refugia or climate cold spot, which are the least exposed. Then we could think about to enhance landscape connectivity to allow species to move and adapt to climate change. And then it's also very important to conserve genetic and the ecological diversity on which adaptation potential is based. And then in most extreme cases, we can improve more action like habitat restoration or creation of microhabitat, or in most extreme cases also translocation of species. So in the next part, Valerio will talk about specific action of adaptation.
Yeah, thank you very much, Marta. I think this gives a good insight into scientific work that then can be used in practice. We also saw a bit, that flat land is more affected in terms of velocity, and in terms of magnitude, it's more visible in the mountains. And derived from this knowledge, I hope we will be able to derive from that good measures to somehow adapt if possible. So if you have any questions, we can allow for some. I cannot see any in the chat, but I saw that people like the presentation. There is one question from Heidi Sirapax in Wildlife Finland. She would like to ask why SSSP 4.5 was not used in the analysis. I have understood that this is the current rate of emissions. May I ask the Sapienza team to answer to this?
So there's different scenarios, and then we choose like the three that could best represent uncertainty, let's say. So we choose the first one, 2.6, which is the more sustainability one, and then 3.7 because we consider it as the business as usual one. And then we went for the most extreme SSP 5.5. So yeah.
I hope this answers your questions. Your question. I cannot see any other. I get a thumbs up. This is good. Thank you very much, Marta, for your answer. Now let's turn our heads to Valerio Mezzanotte. He holds a master degree in ecobiology and is a research assistant at the Biodiversity Change Lab at the Department of Biology and Biotechnics in Sapienza, University of Rome. And he will guide us through the steps we need to take when we would like to apply the climate change assessment tool that has been developed at Sapienza. I have to say that the tutorial is freely available on the NaturaConnect learning platform, and we will sneak into this with the help of Valerio. Valerio, the floor is yours.
Thank you very much. Yes, let's start with the NaturaConnect learning platform, as you were saying. The NaturaConnect platform is freely available for everyone, so we encourage you to take a look at it. You are since you are joining us in our webinar, you are definitely part of our target audience, which includes biodiversity conservation managers, spatial planning technicians, and data analysts. And the objective of the learning platform is, of course, to give you the basic information you need to actually use our data for your own purpose of conservation action. And it allows you to be empowered and to have access to this data and to have better to be able to better understand them. So yeah, I strongly advise you to take a look at the learning platform. The 3.2 modules in the section within section 3 is contains the things that we're gonna talk about in a minute. So we've talked so we were talking about practical application of these climate metrics, which Moreno and Marta introduced you, and we're gonna go through different possible condition in which a protected area can be found within. So we of course are talking about a multi-scale, multi-dimensional issue. We have different possibilities in terms of climatic condition, but we have also potentially different action and different actors involved. So we are going to provide you with some information for restoration practitioner, protected area managers, and even regional and national authorities, because of course the scale influences the potential actions, and of course even the conditions are crucial. So this is still a part of the tutorial on the NaturaConnect learning platform, so you can download the full PDF from there. The first thing is how do we define when a specific climate metrics can be considered high or low. For example, for velocity, we know that there are limits to dispersal ability of species, and we can select optimistic dispersal ability based on groups or other kind of information. For example, we assumed half kilometers per year for amphibians and reptiles, and 3 kilometers per year for mammals and birds. And on the other hand, for magnitude, we selected the 5.33 threshold, which is based on the which is a statistically based threshold. And when this is exceeded, it indicates that a novel climate will be present in this area. So this information is crucial, and when we combine these two metrics, we can get into 4 possible scenarios, and now we are going to go through all of them, all of these possibilities. For example, a certain protected area could be found in an area in a protected area with a high value of local velocity and a low magnitude value. And in this case, this means that there will be modest changes in the climatic condition compared to the baseline historical climate in the focal cell, but not in the surrounding areas. So this has a profound implication for restoration for all actors of restoration and conservation projects. For example, if you are part of a restoration project, you should focus on increasing the connectivity between patches and create corridors to facilitate and allow for species movement. If you are a protected area manager, it's important to increase collaboration between nearby protected areas. And if you are regional and national authorities, you should focus on informing the land use decision and increase the need, highlighting the need for corridors and stepping stones habitats. On the other hand, if you are in a protected area which is going to face low velocity and high magnitude value, this implies that the protected area will face slow movement of climatic condition across space, but with intense local change in climate. So suitable climate will be found nearby, but not within the protected areas. This implies that if you're a restoration practitioner, you should and you have to carry out a restoration project within this case. You're gonna have to focus on action and species that will be able to adapt to this extreme local shift. And so it's crucial to carefully evaluate species climatic niche during planning. Instead, if you are a protected area manager, you should focus on the creation of micro-refugia, for example, shady patches or water features like artificial ponds, in particular for amphibian species. And of course, if you are regional and national authorities, you should focus on embedding micro-refugia into potentially a national planification of this kind of micro-refugia. Instead, this is the worst case scenario. What happens if the protected area is found within an hotspot of climate risk? In this area, the climatic condition will change rapidly and abruptly, potentially, with high local intensity. And this has profound implication for conservation and management actions, since if you're a restoration practitioner, you should try to avoid this area if it's possible, but this will not always be the case, since and in the case in which you have to carry out restoration within this area, you should really think more about future climatic condition rather than refer to historical condition, in order to avoid wasting efforts and money. Instead, if you are a protected area manager, you should consider a multifaceted approach, consider assisted migration, and implement extensive monitoring and even experimental adaptive management in order to try to manage the system. Instead, if you are a regional national authorities, you should really make sure that this area, that conservation and restoration action are really important for this area to happen, and maybe you should prioritize other area if it's needed, based on climatic trade-offs. Instead, the best case scenario, if your protected area is found within a climatic refugia, these areas are the most suitable. This will be the conservation strongholds in face of climate change, since they will offer very favorable conditions for long-term species persistence, and these are the perfect area for carry out restoration projects. And so you should consider restoring degraded climatic refugia, and especially if they are close to nearby biodiversity-rich areas, since they could effectively act as a place where biodiversity can move from a more exposed area. And if you are protected area management, you should, of course, increase connectivity to these climatic refugia and allowing for species movement, as I was saying. And also, you should monitor this area to benchmark the impact of climate change, to have a baseline to compare these impacts with, in comparing them with other areas. As I was saying, if you're a regional national authorities, these refugia area are conservation strongholds, so it's crucial to avoid disruptive land use and ensure protection and connection to this area. One practical application of what I was saying before, what I've said up to now, is that can be seen here in the picture. Here we have an images and of the climatic exposure of a Italian protected area, which is found within the Central Apennines, and it's rich in endemic Italian species. Particularly, we can see in the picture Vipera orsini, which is a snake of the Italian fauna. From the images from the climate metrics, we can say that the north-facing slopes of the mountains can be considered as climatic refugia, while on the other hand, we can see that an extensive rural area outside the protected area will be facing extremely high values of for both climate metrics, and the same is true also for the top of the mountains, which will face really high exposure. We know that this is called the escalator to extinction problem, and of course that's true for some species. Yes, so this is an example of how to apply these, how you can visualize these metrics for your own protected areas and take informed and tailored conservation action based on combined information from climate metrics and local knowledge of species. Okay, we've talked up to now about how to use these metrics. Another important thing to talk about is how to elaborate these climate metrics by yourself. You will find also these within the NaturaConnect learning platform. And here we are going to go really quickly through the elaboration
Yes,
of analog.
Valerio, please, may I ask you to close soon? We are over time a little bit. Sorry to interrupt
Okay.
you. Yeah.
Yes, of course. So you can take a look at this from the web, from the NaturaConnect learning platform. It's quite simple. You will find all information there. Just take a look at the Danube-Carpathian area, which is shown here with a focus. You can see the most and least exposed area, and for all the technical part, just take a look at the learning platform. You can this is my last slide. I strongly encourage you to read our work. It's open access and published on Global Change Biology, and you can download our data, so you do not need to recreate your own climate metrics. If you are within Europe, you can just download and use our data. And yeah, once again, there is the link to the learning platform. Thank you.
Oh, thank you very much, Valerio, and sorry that I hustled you in the end to close quickly. I think this is a quite practical tool that you all can try out, even if you do not have the data. The data are available from NaturaConnect. They were collected and brought up and stored at an open access Zenodo. So the links are there. So I hope there will be many people interested to assess their own areas, be it protected area or for land management. I saw one question from Maria. She wanted to ask if we could share the links of the publications for the last 3 presentations, and I think this is what we can do easily.
Yes, of course.
Yeah. Okay.
Yeah, you can take a screenshot. There will be the recordings, and then maybe we can put them in the chat also.
Yeah, we can also put it in the short wrap up of the webinar. Good, time is flying. I'm sorry, it's super interesting altogether, but we are now turning our heads. Maybe Jose can share Now we are in the next section of the webinar, we will dive into practical applications of climate change assessments and applied measures from two different parts of Europe. One will be Spain and the other one the Balkan-Carpathian region. And obviously climate change causes many troubles in Europe, especially in the Mediterranean. We followed the news on recent floodings, but also the frequency of droughts and forest fires is increasing. Large carnivores leave the forest because of food scarcity in their home ranges, and we need to react on these threats and work on strategies to cope with this new situation. So I welcome Jose Atauri, who works for Eurobac Spain and was part of the Live Red Bosques Clima project. He will tell us about this project, where he was a coordinator director, and the project dealt with the assessment of forest vulnerability to drought and supported adaptation strategies in Spanish forests. Jose will present the methodology of drought risks assessment related measures that has been recently published. So Jose, the floor is yours.
Thank you very much, everybody. Thank you for the organizers for inviting us to this webinar. I'm going to summarize the results or some of the results of our recently finished project, Red Bosques Clima. It has been running through the last 4 years and have just finished. And we have been dealing with adapting forests to climate change, specifically in protected areas. So we have focused on forests because obviously for their importance at the European level, we have a very high diversity of forests. This is a very nice map of the different types of forests in Europe, which are very different from east to west and from south to north. And we have focused on the Mediterranean forests, which are particularly vulnerable to climate change. Forests in Europe represents a very large area. It's more than 50% of the area. They are more of 50% of the forest area. Is protected under Natura 2000. So they have a very high conservation value. That's why we are very interested in conserving forests and also to adapting forests to climate change so that they can deliver all the services that they deliver to society. And this is in a context that has already been mentioned here, a context of climate change affecting Europe in a very specific way and in the Mediterranean also. As you can see, we are expecting to have higher temperatures in average than the rest of the continent in the south. And drought, as you can see in the right side of the picture, drought will be a very important hazard derived from climate change, affecting especially southern countries in Europe and northern countries in Africa, of course. So we have focused on forests and on drought as the main hazard that we are facing. We have to mention also how forests differ from north and central European forests. In the Mediterranean, we have a lot of forested area, but with a very low production compared with Central Europe due to climate constraints and topographic constraints. Wood production is low. That makes it difficult to manage to have a sustainable management in an economical way. So many parts of the forest are not managed at all because it is not profitable. And we have to mention also a problem that it's very important in central Spain, especially and north of Spain, is that of rural abandonment. We have large parts of the country with almost nobody. So there is no people caring for the forest or managing the forest or implementing measures that can help to adapt forests to climate change. Those constraints are very important. The low productivity, low economical return of forest management, and very few population density. So in this context, we choose drought as the main climatic hazard, and we have been working on how to adapt forests to drought. Okay, we are having increased frequency of heat waves, along with long-lasting droughts, which makes this a very high hazard for forests. You can see here a map of how drought has been affecting Spain in 2023 when you have a very long-lasting drought in all the country. So what we first made was to make a literature review of what the scientific evidence is available or about what features of the forests are related to resilience to perturbances, to disturbances, and specifically to drought. This was made, I have to say it, by one of our partners, the Center for Forest Research in Barcelona, in Catalonia, the CREAF, which were the scientific part. Structural heterogeneity, the forests which are diverse in age classes, in sizes, with non-continuous canopy, but gaps are more resilient to drought. And of course, diverse forests are also more related to this resilience. Tree species diversity is very well related to resilience to disturbances, but not only species diversity, but functional diversity. We need different the species, but with different functional traits. That is, with different, for instance, embolism resistance, rooting depth, etc. I cannot go in very much detail on all of this, but those are the main characteristics of forests that makes them more resilient. And we found that this is precisely what are the main attributes of mature forests, where we have trees of many ages, of many species, of many sizes, with clearings, with deadwood, and with a lot of diversity, which makes them more resilient to climate change. That is what we are trying to foster or to favor in managed forests, to make them more resilient. So we conducted a risk assessment following the IPCC scheme, and this very similar to what the colleagues from the Sapienza have been explaining. And we assessed exposure and vulnerability to assess the risk of drought. In terms of exposure, and we are evaluating at a stand level, a very local level, a particular forest stand. We assess the climatic exposure, how this place is exposed to drought, and how these main species are adapted or not to the local climate. And also what we call a geographic exposure in terms of how the place where you are is exposed to drought because of its topography, its solar radiation, or the development of the soil. And the second component of risk is vulnerability that we assessed through assessing the forest structure, what makes the forest more vulnerable to drought. And we assessed some criteria about structural and functional vulnerability. You can see here the criteria we used, the basal area, diversity of age classes, diameter of the trees, tree species diversity, and resprouting capability. With all these criteria, we identified for each of them some quantitative index or indicators, sorry. Here we have the complete table. It's quite simple index. For each criteria, you have one or two indicators. Those about exposure are obtained on the geographic databases using a GIS. And those about vulnerability are obtained through field sampling in field plots, following a protocol that we developed for the project. And you can download it from the web page in the project. The result is that you can have an overall index for drought risk for your particular forest, but also to assess how each of the characteristics of the forest are more or less vulnerable. I have here an example of how we applied it on the ground in one particular protected area in Valencia, in the east of Spain, in a plantation of Pinus pinaster. This is a particularly vulnerable kind of forest because, as you can see, it's very even aged. All the trees are the same species, the same age, the same size, and even the same distance among them because they were planted. So this is very vulnerable to any perturbances, of course, drought. And here you have the results of the index. In the right side column, you have the value of vulnerability for Pinus pinaster for the whole Spain. Using the inventory, the data from the National Forest Inventory, we can calculate the vulnerability, average vulnerability of each component of the index for the Pinus pinaster, an average in Spain. And in the left side, you can see this actual stand. And in red, we are worst, and in green, we are best than the average. So we can see here that there's, of course, we cannot deal with exposure. We cannot manage the climatic or geographic exposure as forest managers. We cannot modify solar radiation or topography, but we can manage the structure of the forest, and we can identify here what characteristics of the forest are responsible of the vulnerability. For example, here the diameter of the trees is something that we can manage. We can cut trees in a way that we can promote a diversity of diameters. We can promote a diversity of species and so on. So this is a way to design the adaptation measure in a coherent way with the vulnerability index. And that's what we did in here. For example, we designed an adaptation measure that consisted on thinning the forest, but not in a regular way, but on these circles. In each of these circles, we reduced very much the density of pines and let all the Quercus species that are on the understory to grow. So we will have this in a medium term. We will have this forest that is absolutely continuous, homogeneous, and non-diverse. Converted in a forest that will be heterogeneous, with gaps and with a more diversity of species. So what we are trying to do is to change the landscape and the forest from this stage, where we are now, where we have very large continuous extents of forest of one species with a very dense canopy, only of one species with almost no understory, and to promote that this will evolve to this kind of situation with forests in a more diverse canopy, with gaps, with open spaces, with old trees, along with young trees, with clearings, even with some dead wood. That has been seen that to be more resilient to climate change. And well, that thing is a very quick summary of the project. We have made this in 5 pilot sites, and I am showing you just one of them.
Thank you very much, Jose. Very interesting, very hands-on measures you took, and we see diversity is always best. And it seems that your methodology includes a lot of field work as well. So this is really can be done on a really local level and in very detail. But how much field work is estimated to do for creating the index?
Not so much. And field sampling, it's quite simple. It's a standard sampling for foresters. Is the kind of work they do, and there are no different variables to measure that they don't usually do. Just 3 heights, 3 diameters, and in a circular plots, and maybe in one when the day of fieldwork, you have all the data available.
Okay, good. Thank you very much. I was just interested to how this works. Are there any other questions in the chat? Do you have any? Otherwise, I'm sharing the presentation of our next speaker. So let me welcome Maria, a specialist in large and small mammals biology, and she managed various Interreg projects on various topics, and currently she contributes to the Interreg Forest Connect project that deals with climate-driven food scarcity of large carnivores in forests, and the project implements measures in forest in the Carpathian and the Balkan region. And yeah, Maria, we would like to hear from you if I can put this on the presentation mode. Now it works. Maria, the floor is yours.
Hello, everybody. Thank you very much, Hildegard, for inviting me here. I'm very happy to share with you the two of the measures that we applied in the frame of Forest Connect project to adapt to climate-driven food scarcity for large carnivores. First, next slide, please. First, I will present you the project. So it is focused in 3 regions. This is the Carpathian Mountains, the Balkan Mountains, and the Dinaric region. It unites 6 countries and 13 project partners. The countries are Bulgaria, Serbia, Romania, Montenegro, Slovakia, Ukraine, and Austria. And it's funded under Danube Regional Project, and it's very ambitious but quite short. It's 2.5 years. Now we are in the last period, so we had to work very hard to face the ambitions that the project has. And next slide. I will show you a little bit of background. This is one very funny photo. It's not quite visible, but this is our little bear, several months old, that is climbing on a fruit tree that was found by our team and saved, rehabilitated, and then released in the wild. And we found it on a fruit tree. I think it was the plum, the common plum tree, and the Eastern Balkan population that is inhabiting Bulgaria and Greece is the most herbivorous of all the bear population in Europe. Up to 75% of its food is plant-based, mainly forest fruits and forest nuts, beech and oak acorns, and this also leads to relatively low human-wildlife conflict, because the studies found that only 10% of the food of the bear is human-sourced. But this next slide. But this situation is changing with the climate change, because in dry years the food in the forest is very scarce. The beach they have very low harvest, and so the bears cannot find food easily, and they very often go to the human settlements where it's much more easily accessible, the food. And so it's already well documented in Bulgaria, for example, that the cases of bear-caused damages are much higher in years when that are very dry and when the beach don't have enough acorns in the forest. And next slide. This situation inspired the actions in the Forest Connect. We wanted to enhance and improve the habitat in the forests, so that the large carnivores and in general the wildlife can find much more food there. 2 types of measures were applied in the frame of the first measure. So 26 hectares were planted with 10 different fruit-bearing species, and we focused on on places in forests that were impacted by forest fires, for example, or some natural open areas that were overgrown. And in the frame of the second action, the pastures were cleaned, because in this part of Europe we have the same problem that Jose already presented for Spain, that the rural population is decreasing, and so the pastures are abundant, and this unique mosaic of habitats is disappearing. So on 663 hectares, the pastures were mowed, and the meadows were cleared. And this happened in the 23 sites in 6 countries. And the next slide, on the next slide, you can see where exactly our actions were they took place. They were in Balkan region, in Bulgaria and Serbia, just on the 2 sides of the border, and also on 3 places in Carpathians, and plus several natural park. Just a second, please. Sorry. So, and also in several just a second. And also in 4 protected areas, one in Slovakia, this is Uvejski Raj Natural Park, and 3 others in Montenegro. And on the next slide, this is the list of the species that we used for planting in order to adapt for the climate change and the expected effects. We did we had a forest expert that made a survey on the ecological and topological requirement of these species. They are mostly from Rosacea family and were proved to be part of the large carnivore diet, mainly of the bear, but also for the wolf. So these are only native species, and they were chosen by specifically. So for each site, it was evaluated if this species is appropriate now, and if it will be appropriate in the future climate scenarios. Also these are species. We tried to choose species that don't overlap in the fruit bearing time, so they can assure food for longer periods, not only for a fraction of the period. And last but not least, we prioritized the seeds from the local sources, and these are also pioneering species. So even in natural conditions, they often appear in places that were damaged by some disasters. And so with our activities, we enhanced and faster this natural process. And next slide. The next the other measures was, as I mentioned, cleaning some overgrown pastures and meadows, so they can provide food for not only for the large carnivores but also for their prey. To enhance the grazing opportunities for ungulates, and also in some places there was no need to. There was no need to plant additional fruit trees, but they were already present in the landscape. We had to found them and improve the conditions for them, clean a little bit the surrounding vegetation and make them more easily to be found and to bear more fruits for the animals. In the next two slides, I will present you some examples for more that are especially interesting in the frame of our project. The first is from Montenegro, where the activities were focused in areas that were damaged by forest fires, and there the wood was preserved at the landscape and was used to make terraces where the fruit trees were after that planted, and this provided additional value of reducing the soil erosion and also providing preserving the dead wood at the ecosystem, which is very important for a number of species. The next example is from Slovakia, where our activities were implemented together with a festival, and some of the sites were mowed by hand in the frame of a local festival with the active participants and volunteers for the local communities, where this hand mowing is part of the traditional activities, and it's preserved now. So we have this double benefit, not only for improving the habitat, but also for involving the local people and showing that very often this traditional knowledge is beneficial, traditional knowledge and practices are beneficial not only for the communities but also for the wildlife, because in Europe there is a long history of coexistence in a lot of countries. And on the next slide, I have
May I ask you to finalize, because we are short on time. Thank you very much.
Yes,
Sorry
so
for saying.
these are just the recommendations to combine species and to assure long-term maintenance and for the terrace construction that I already mentioned. Yes, thank you.
Good. Thank you very much, Maria. I think this was also a very excellent example from the field, what directly can be done. If there are any questions, please let us know in the chat. Marit, can you, because now I cannot see it.
Yes, there's one question from Lucas. He's asking Maria, what is the main goal of these measures, maintaining the large carnivore population, or rather preventing conflicts with humans related to searching for food in the vicinity of people?
These were both aims. The one is to maintain, to provide food and to decrease the conflict, and the other is also to improve the habitats in these targeted areas, because they are transnational corridors that are connecting the populations of, for example, bear between the Balkan and the Carpathian region. So they are quite important. And we would like that the bears find better habitats there, so to enhance the movement between the population and between the optimal habitats.
Mm-hmm. Thank you very much, Maria. I hope the question was answered. Good. I mean, out of time. Anna has another question to Jose. In your example, where did the mean data for the tree species vulnerabilities come from? And was it ready for use for all the metrics, or did you have to make calculations? I'm thinking if corresponding data is available in other countries as well. Jose, did you hear it? You need to unmute or?
Yeah.
Yeah.
Hello.
Okay. Mm-hmm.
Yeah, the data for species vulnerability come from available databases that are online. You can find in the web page all the literature you need to replicate the index in any other country. So yes, most of the information comes from published database, which are public. I am not sure whether it's available for any other country. That I'll have to check with the research center that actually developed the index.
Thank you very much, Jose. Anna, I hope the question was answered. I think yes. Now we would like to trigger a little bit of a discussion, but as we are so many people, we would like to go back to the Menti. Marit, maybe can you share the Mentimeter, please? It's the same Mentimeter. If you are still on this, we will ask you some questions. Yeah, I think. Oh, we are 40 who joined, so let's take the first question to you. We were wondering if you have used climate change metrics in protected area planning and management in your circumstances, in your context, in your working field. This would be interesting to know. I'm pretty sure there are many more assessment methodologies and work that has been done, and would be interesting to know. Okay, I see more of the people do not use these climate change metrics. Okay, let's go to the next question, because we're a bit short of time, so I want to a little bit speed up. The next question would be, do you intend to use climate change metrics for protected area planning or management in the future? So there are three options. The one is yes or no. The other one is yes, but I do not know enough yet. I see. Everybody wants to use it. Some people know not enough about it. Some people, yeah. Okay, so I think climate change is a topic that really affects us all, and we need to deal with it in a way or another. Good. The next question is also what additional information or capacity on climate risk assessment would help you to adapt your park or region more effectively? What kind of data or financing or people or staff or knowledge of staff in your area? You can type it in some words, some fragmented words or some keywords, and it will be shown. No additional information or capacity. Okay. Let me see. There is no any additional information. Data on species vulnerability. So answers come in. I'm glad. Or maybe links to the available resources. Also probably some training how to use them. Better understanding on how species and nature types will be affected. That's true. I think this is learning by doing. So the more projects will be implemented on these topics, the more we have lessons learned and the better we can adapt, right? And another comment was endemic species and requirements or ecology are missing, or how an analysis for species that can react on climate change. And does it mean mainstreaming, I suppose? Mainstreaming this topic in all of the field of expertise in all the sectors. This is true. Okay, and the last question we do have is, what are your main gaps and challenges for implementing climate change adaptation measures in your park or regions? So is it only a knowledge gap or information gap, or are there other gaps as well? Do we have enough staff? Is financing enough, or do you see some options for receiving funds to implement the measures you would like to do? Is it supported in your country? I think there are variable gaps and challenges around. Sometimes process is time consuming. That's true. This is why I ask Jose how long it takes in the field to get the valuable information to be able to work on the index. Lack of time and expertise as well. So I see there is a need of capacity building program towards climate change assessment and developing measures. Sometimes not much you can do to reduce climate change. This is true. I mean, we are talking about adaptation and somehow mitigation, and in some cases we will not be able to do anything meaningful to help the ecosystem survive, right? Then we have good examples and case studies, and advocacy should be emphasized. Knowledge staff and also legislative registration in restrictions in protected areas, but mainly lack of financial resources. Financing pops up several times, and knowledge gaps. Also lack of scientific background of authorities responsible for protection planning. Yes, all true. Thank you very much. It's very interesting to see, and also interregional cooperation. True, nature does not know borders, as we know. Thank you very much. I think you can still type in some questions, but I would like to give the word to Moreno Di Marco to a little bit summarize our.
Yes. I think we are a bit short on time, so instead of doing 5 minutes, I'm going to do 2.5 minutes, if that's okay.
Yeah, true.
So, first of all, it was impressive. Congratulations to all the speakers, and thanks everyone for participating. It was an impressive event. Let me try to summarize my understanding of it. Sorry, you disappeared. No, there you go.
Here? No.
Yes. Can you still hear me? Yes.
Yes. All fine.
So first things, what we learned today, I believe we learned once again that there is an important difference between climate mitigation and climate adaptation. The difference is climate adaptation is incredibly complex. Mitigation essentially consists in reducing emission, and that's it. Adaptation is no silver bullet. We have heard it from Jose and Maria. If you want to make your species or your habitat adapted to climate change, you might need to take different decisions depending on where you are and what species you are dealing with. In terms of what can be done in terms of adaptation action and how challenging it is, there is a trade-off. To some extent, there is avoidance. We could try and avoid the areas which are facing too high climate change, too rapid velocity of climate change, too high magnitude of climate change. But this is not going to work. By far, this is not going to be enough for 2 reasons. First reason, if you already have a protected area, that area might fall in, quite likely actually, in a part of the world, in a part of Europe with high climate exposure, and then you do need to adapt. Second hypothesis, you might need to establish a new protected area, and you cannot possibly avoid climate change. That protected area perhaps is focused on an endemic species, a particularly restricted habitat, and so the protected area must be there regardless of climate change. And this is where adaptation is paramount. There is no other option there. The issue is resources are limited. So tools like those we saw today from Jose, or approaches like the one we saw from Maria, those are important, but there is just no way we can do these adaptation strategies everywhere at the same time in Europe. And this is where data such as the one that Marta Valeri have presented to you can be effective. They can tell you where you are facing the highest risk, where is most paramount, more important to adaptation, and where adaptation must happen in the next 10 years or 20 years or 30 years. So the key word, in my opinion, here is prioritization. Just in the same way in which we prioritize the location of protected areas, we should prioritize the deployment of climate mitigation action, because we cannot do everything at the same time, and some part is going to need priority action. And this is something which must be coordinated not only at the national scale, but at the European scale. Last word, because I think we're approaching the end. Climate change, climate science, climate policy. Climate scientists and biodiversity scientists doing climate analysis are working very fast. New knowledge is produced every year, and this is much faster than the ability of policy to uptake that knowledge. But that doesn't matter, because climate velocity is faster than policy and faster than science. So I believe we need to think about our next priorities. Do we need to produce more knowledge and more science, or do we need to invest more as scientists, more of our time in improving the uptake of our knowledge. I believe there is time that we think about that, because it doesn't matter if we produce another 1,000 paper next year, unless, I mean, if that knowledge is not implemented and uptaken, this is not going to be effective. So this is a message for scientists connected here. We need to invest more time and more resources into making sure that our products are uptaken, and this also emerged from the questionnaire. That's it from my side.
So thank you very much, Moreno, for these excellent closing words and excellent summarizing our webinar. So I will stay only with the next steps we want to take. So the recording presentations and post-workshop briefing, or it's not a briefing, it's a wrap-up. You will find on the NaturaConnect site, but you will also receive it, and the NaturaConnect learning platform links and all the links to the presentation, to the publications and so on will be also included. And I would like to kindly invite you to our next webinar, Shaping Tomorrow's Landscapes, Land Use Futures in the Danube-Carpathian region, which will be presented at the 23rd of April 2026 from 10 to 11:15. So it's a similar format as we had today, and you're very warmly welcome. And the last but not least, we always have the obligation to collect evaluations of our events. So please, if you could take the time to evaluate our webinar, you have the QR code here or the link to the evaluation. We would be very happy. And thank you very much to be with us for the entire webinar. We are happy that we could present it, and we are and we see that there is a lot to discuss around this topic, and we will keep this up for the future. So thank you very much for joining. Thanks to speakers, and yeah, hope we will see you again in another webinar or wherever. Thank you.
Thank you.
You know.